Hello. I hope your guys' test went okay for you yesterday. I hope you did your best. I'll get those eventually here soon and get your grades put in the system for that as well. Make sure that you guys are turning in your questions that were due from the new student welcome days. You guys have got to get those in. That way I can let the office know you completed them. That way you're not marked as absent, at least in my class. Okay? So today we're going to go ahead and jump into section 5 of chapter 2. We're going to deal with complex numbers and roots. So, remember me telling you about imaginary numbers? Well, today that is what we are going to start looking at. Now, just because I say imaginary doesn't mean that it's ridiculously hard. This is probably one of the easier things that we're going to be doing, honestly. But before we jump into that stuff, I want to go ahead and do this warm-up along with you because, one, you have to know how to break down radicals, your square roots, like number 1 on the warm-up. And for number 4 and 5 right there, you have to know how to find the zeros of the function. That's the completing the square portion. Alrighty, so let's go ahead and look at the square root of 108. Let's go ahead and break this down. So let me pull up this handy dandy little whiteboard I get on this, and there we go. Alright, so we have the square root of 108. So to break it down, we need two things. What number goes into 108? Well, I know 108 is even, so I know it's divisible by 2. Okay, 2's prime. It's not like I can break it down anymore, so I'm going to go ahead and circle it, like I like to do. And what is left? Okay, well, 2 times 54 is 108. But 54 can be broken down. It's still even. So I'm going to go ahead and break it down by a 2 again. That's prime, so I'm going to circle it. And then 2 times 27 is 54. 27 is divisible by 3. 3 times 9. And then 9 can be broken down into 3 and 3. So now, remember, well, how does something come out from underneath of the square root on this problem? Well, it's a square root, so you have to have a pair for it to come out from underneath. So if you notice, I've got a pair of 2's. Alright, so that's going to come out from underneath. I also have a pair of 3's. That's going to come out. I've got that radical symbol still there. And this 3 right over here that doesn't have a pair is going to be put back underneath of that square root symbol. Alrighty, so now we're one step away from having this finished. You need to simplify that 2 times 3 on the outside. Well, what's 2 times 3? 6, and then the square root of 3 stays right there. So that is your breakdown of the square root of 108. These two things here are the same. They're equal to one another. Okay? Alrighty, so back onto here. Now we're at finding the zeros of each function. Number 4. Let me grab my paper. Okay, so let's go back to my little whiteboard. And we're going to get the first one on here. The first one is x squared, I hope you can tell it, that's a squared, minus 18x plus 16. Okay, and I know on your paper it says f of x. Well, I'm just going to leave that off because in order to find the zeros of each function, what do we have to do with this function? We have to set it up equal to 0. Now we're here where we're just going to start completing the square, which means the first thing we got to do is move that 16 over to the other side, by which case we're going to subtract it. Alright, and that's going to leave me x squared minus 18x, and that equals negative 16. Now notice I went ahead and left me some space because I need to add a box and add a box. Alrighty, so what goes in my box? How do I figure out what goes inside my box? And I hope by now you've got this down and memorized. Inside the box is b over 2 squared. So my b value on this problem is negative 18. We're going to divide that by 2. So we get negative 9. Square negative 9, you get 81. 81 is what goes inside these boxes. Alrighty, now that we got that square completed, we now need to factor this left-hand side. And remember, it's a perfect square. So we've got x, because x times x is your x squared. What times what is 81? Well, 9. And whatever symbol is there goes straight down. Now simplify that right-hand side. We got negative 16 plus 81. Negative 16 plus 81. So, what does that give me? Hopefully you're all saying 65. Alrighty, so now that we have everything broke down ready to roll, we now have to take the square root of each side. So let me change colors. We're going to square root this side. Out comes x minus 9. Square root this side. Out comes plus minus square root of 65. So you can go ahead and try to break down 65 if you'd like, but 65 is 5 times 13, and 5's prime, 13's prime. So you cannot break that down any better. So we're one step away from having this problem done. We need to get x all by itself, so we have to move that 9 to the other side. Alrighty, so how do we move it? You have to add it. That's gone. That leaves x, and we'll put the little answer right over here. Okay, so x is going to equal, and then I got to add 9 to this side. So what this is going to look like is 9 plus minus the square root of 65. Alright, so I apologize for the sloppy handwriting. It's really hard to write with this little stylus pen that we have, or that I have, but it'll make do. Okay, so that one is done. Alrighty, so I believe on your paper you do not have an extra problem, which is great because I don't really want to do that one anyway. So I want to go ahead and get moving on to what we're going to do today. So, complex numbers and roots, we're going to define and use imaginary and complex numbers, and then we're going to solve quadratic equations with those complex roots. Some vocab words that you might see. Not really going to go into too much detail on those right now. Okay, so before today, we have dealt with roots, and we've talked about roots as the place where the quadratic crosses the x-axis. So we've talked about ones that look like this. Noticing that how many roots are there? There's 2 distinct real roots, meaning because they cross that x-axis. Alright, we've also looked at ones that, might look like something like this, where we have a double root because that vertex lies on that x-axis. So there's only one real solution there. Well, the ones that we haven't dealt with yet are ones that might look like this. What's the difference between the one I just drew in pink and the one that you still see there? And maybe the other one where I have the 2 points. Notice that third one, I'm talking this one right here, does not cross the x-axis. So when we talk about roots, there's no real roots. It doesn't cross that x-axis. But we can find the imaginary roots. Okay, so let that sink in. There are imaginary roots for that graph that does not hit that x-axis. So what you need to take away from this slide right here, okay, the only thing you really need to know about this screen here is specifically this part here, imaginary unit. So when I talk about an imaginary number, I'm not talking that it's just any random imaginary thing. It actually has a distinct meaning. The imaginary unit, which we let I, lowercase I, represent, it is the square root of a -1. Square root of -1. Okay, so this little box here just goes into more detail, explaining the algebra version of it and the numeric version of it. Basically, what you need to know is that I is the square root of -1. Get that in your heads. Okay, so the first few examples that we're going to have, we're just going to basically break down radicals that have a negative underneath the radical. I might have said that wrong there, sorry. Okay, and now here's how easy this is. Anytime you ever have a negative underneath that square root, you automatically just bring that out front of the square root symbol, but you put it as an I. So here's what we have. 5i square root 121. Okay? Pretty simple, right? But the only thing is we've got to finish this problem because 121 can actually be broken down. 121 is 11 times 11. So I have a pair of 11s. That means they're going to come out in front of the radical. So that means I have that 5i that's out there, and it's multiplied by that 11 I'm going to pull out. Just like combining like terms, or in this case multiplying, the numbers get multiplied together. 5 times 11 is 55, and that I just stays right there with it. 55i. I hope you're saying right now, wow, that was actually pretty easy. Okay, so let's try another one. Let me switch up my color. I'm bored with that one already. Okay, so on this problem, we've got the negative square root of -96. So that negative that's underneath the square root, I'm going to pull that out front as what? As I. That negative that's out there already has to stay. So this becomes -I square root 96. Okay? So I'm going to pull that 96 over here so that we can break this down. I know this is divisible by 3. And then it'd be 3 and 32 to make 96. 3 is prime. I'm going to leave it, circle it, break 32 down. 4 and 8. 4 breaks down into 2 times 2. Okay, I'm going to shorthand this one. 8 is 2 times 2 times 2. So let me circle all these. And there we go. So now we've got to pull out front what has pairs. So if you look, I have a 3. Do I have any other 3s that I can pair it up with? No. That means that that 3 is going to stay underneath the square root. Alright, I've got this right here. I got a pair of 2s. So I got 1 2 that's coming out, another 2 that's coming out, and then this one here is going to be by its lonesome. It's going to stay underneath the square root. So when we go to write our final answer, let's look and see what all we have to pull out. We're pulling out 2 and a 2. So we're going to multiply that back together as 4. So that's going to make it a -4i. We put back the radical symbol. What's left underneath of that? A 3 and a 2. Multiply that back together. 6. -4i square root 6.